very fast movement. That's what happened in the solid state. The particles are arranged in regular arrangement and they are vibrating in their position. Okay, they are very close to each other and unable to move freely. The liquid movement is faster, more rapid, free movement, but within the container. Okay, and they still close together to some extent, the particles. The gas is very fast, large spaces, free movement, and irregular arrangement. So, a state can be converted to another by changing the kinetics of the particles. And the kinetics of the particles are changed by change in temperature. So, as temperature increased, as more energy will be absorbed with the particles, and as the particles get more energy, they will move faster. And as they move faster, they will leave spaces between them, and the regular arrangement of solid will be distorted. There will be no regular arrangement and will be converted to another state. So let's start by solid. So if we get a solid matter, then if it is heated gradually, particles of the solid will gain energy, and as they gain energy, they will move faster and will leave space between the particles and then will be converted into liquid. If we continue heating, liquid particles will gain more energy, will move more and more fast and more rapidly and more freely, and more spaces will be formed, and then the liquid will evaporate and will form a gas state. So what are the intermolecular spaces? The intermolecular space is the space between atoms or molecules in a liquid or gas. And they are small. The intermolecular space is smaller in liquid than that in the case of the gas. So there is something called intermolecular forces. These forces are weak attractive forces that act between molecules. So molecules of a substance has force of attraction between them, and this force of attraction is very weak. Again, don't forget that. So the energy absorbed by heating will change the kinetics of the substance. So the solid will be liquid and the liquid will be gas. When cooled down, the absorbed energy will be lost, will be released, and the gas will be converted to liquid, and the liquid then converted to solid. Here we will come up with what is called exothermic and endothermic changes. Exothermic. So the word thermic comes from thermal or something related to heating. okay, or temperature. So exo means exit or outside. So exothermic change means energy will go outside. Heat will go outside. This is simply, but the definition is exothermic change is a process or chemical reaction in which heat energy is produced and released to the surrounding. So energy exit the reaction. Heat energy will exit the reaction. So in that type of reaction, when we make this type of reaction in a test tube, we will feel that the test tube is hot because the reaction release energy, release heat. Heat is exit exit the reaction. Okay, and delta H has negative value. We'll see how and why. Okay, indo comes from inside, internal, and thermal or temperature or heat changes. So this is a process which is opposite to exothermic. Now the heat will be gained, will be taken by the reaction. Okay, and in that case, in this type of reaction, the test tube will be cooler, will be cold. Okay, so it's a process or chemical reaction that takes heat. It needs to be heated. So sometimes need to be heated for the reaction to proceed from the surrounding. And the delta H for the endothermic change has a positive value. And we'll see how and why later on, next session. Okay, to wrap up what we have today, in short, the idea of today is the heating curve and the cooling curve. The heating curve is the plot which represent the change of the state of the matter by raising the temperature. The cooling curve is a plot that represents the change in temperature, the change in matter by cooling it down, by lowering the temperature. Okay, what happened inside the matter when we heat or cool it obey the kinetic particles theory, which has several statements, and the statements of the particle kinetics are very important. The simple idea is all particles are moving, but the way they move and the freedom of movement will decide what is the type of matter is. If the particles are vibrating in their position and are not freely move and have very short spaces, intermolecular spaces. So this is the solid state. These particles are free to move, have a regular shape. The matter has a regular shape or irregular arrangement, and larger intermolecular spaces. So this is liquid state. If the particles are moving very fast and the intermolecular spaces are very large, this is the gas state. And by playing with these kinetics, we can convert a matter from a state to another state by heating or by cooling. Okay, that's all for today. See you next session and goodbye. If you have questions, feel free to write it down in the comments down below.